Here I'm going to introduce the power triangle. Before we visit the power triangle, I just want to remind you about DC circuits. In DC circuits, we would tend to use P equals IV for calculating power, and I don't mind if you say P equals VI, both the same. The alternative is P equals I squared R. So either of those are appropriate for calculating power in DC circuits. However, in AC, this can cause a little bit of a problem. If we take this formula here, P equals IV, we're literally multiplying the current by the voltage. In an AC circuit, that is this side of the triangle, it gives us something called apparent power. And apparent power is what we call volt-amperes, VA, literally multiplying the voltage and the current together. More normally, we would say kVA. Okay, the problem with this is it ignores the power factor. Power factor is crucial in an AC circuit, and just multiplying voltage by current ignores the power factor, so it will give us an error. If we come down to this line, if you remember what I've told you so far, resistance is the important one in a circuit. Only resistance does useful work and it produces heat in watts. So there we have it. This produces heat in watts, or preferably we would use kilowatts. And this is true power. Being true power, it takes account of the phase angle, and we can use a formula, P equals VI cos phi to determine the power, the true power in any AC circuit, and that's in watts. So that just leaves us this side of the power triangle, and up this side, this is caused by our reactive component. That's an inductor or a capacitor. So this is reactive power. Reactive power, and this is called volt-amperes reactive, or reactive volt-amperes, or we would tend to use kVAR. And sometimes people say kilovolt amperes reactive or reactive kilovolt amperes. So out of this lot, these are the important bits: kVA, kW, and kVAR. This formula for power in an AC circuit is very, very common in exams. It's an important one. So that's the power triangle. This is explained in great depth on your handout. Moving on. So we've met this circuit now many times, and I'm going to try and breeze through some of this bit. From this circuit, we can identify voltage across the resistor, voltage across the resistor, voltage across the inductor, and we have the supply voltage. We can produce a phasor diagram. I'll do that quickly. So there is voltage, there's current, VL, and our supply voltage will be there with phi. So this phasor diagram comes directly from this circuit. I can take that and I can change that into a triangle. I'll draw it in this orientation. So our triangle is going to look like this, with the resistive element horizontal, VR. This side is VL and this is VS. Here is phi. Okay, so we can see, going from that circuit, we can take quantities from the circuit, create a phasor diagram and create a triangle. For this same circuit, we can create several related triangles, all with an identical shape but different quantities. And I'll go through that right now. So the first step is, if we use these voltages, we have VR, VS and VL. For this same circuit, we have resistance, we have reactance, and the combination of those gives us impedance. So if I come down to this circuit, resistance always the horizontal one, reactance up the side, and impedance is our result. For that circuit, we can produce the power triangle, and the power triangle will be, so the power triangle will be KW, KVAR and KVA. So these three triangles have an identical shape but can have totally different numbers on them, but they'll give us the same answer for power factor. In each case, we have the phase angle, and we can get power factor out of this. So cos phi, that's power factor. In this one, it's VR over VS. From this triangle, power factor is R over Z. From this one, power factor is KW over KVA. These formulae are really important, especially this one and this one. In an end of year exam, at least two of these three are almost certain to appear. These two are the favourites. We'll revisit these triangles and the numbers at the end. So just to summarise the information on those triangles, so let me bring that back. Just to summarise the information on the triangles, to get power factor, if you've got a triangle, it's the horizontal over the result, the horizontal over the result, the horizontal over the result. And I've been through that before. It's important that you try and get that into your heads. So I've summarised all of those formulae, and this goes in the yellow strip at the bottom of your handout. I can't squeeze it in on this size of paper and doing the scale that I'm working on, but all of this, if written neatly, will go in the box at the bottom of your handout. Okay, so that summarises it all. Let's do some examples.